Hello, my name is Rafael Orozco, and this is my second argumentative examination. The first problem is to obtain the moment of inertia of a unit sphere with this equation, and in each axis with a density of 1. We will use some formulas, and our limits will be x in -1 and 1, y with this equation, and z with this equation, then in negative and in positive. That will be because x will be our reference point, and in order to reach a y, we will have to use this equation and will be the same to z. Now, in order to make the moment of inertia in each axis, we will use this formula, but for each one. Now, after we make the first integral in z, we will have to change for polar in each integration. That will be for making us much easier the calculations, and we will have the same movement of inertia in each axis. That will be correct because this is a unit sphere. It is said that it will be in the same spots and have the same length in each axis. So if we apply some forms, that will rotate the same way in each axis. Now, in the second problem, we will be to calculate the mass and the center of the mass of a cylinder bounded by this equation and from these limits, and the density function will be this. In order to calculate the center of the mass, first we have to calculate the mass and then the center of the mass for each axis. First, the boundaries. X will be also our reference point. Y will be the same because the cylinder has a circle in the top part, and the z that has already gave us the limit. We will use the formula in order to obtain the mass, and in the same with the first problem. First, in the first integration, we will do it like that, and then we will change it in polar in order to make it easier, having a mass of 7 pi divided by 6. Now we will make it in each point with this formula, only changing the x in the first, the y, and here the z. Also, after making the first integration, we will change it to polar in each case and having different central masses. Now we will have to divide the central masses obtained in each point divided by the mass, having only the z with a quantity, having the central mass of the second problem 0,0,1.60. This will be correct because this is our cylinder, and if we rotate it pi and a half, we will have this expression, and this will be correct because the best way of movement the cylinder will be in C, as we see in this graphic. Thank you, and that will be all.